a situation that allows us to analyze it through use of a system of linear equations. Most of you who've got as far as intermediate algebra have seen systems of linear equations. You've even been asked to solve by hand systems of linear equations. You've also discovered a system of 3 equations and 3 unknowns is difficult to solve, time-consuming, and usually error-prone. So in this video, not only are we going to learn how to translate this statement into a system of linear equations, we're going to learn how to write it in terms of a matrix, and then we're going to learn how to use the calculator, the TI-84, to actually solve that matrix that corresponds to the system of linear equations. So you can stop the video if you want and read this, but I'll quickly go through it. Alan's got $10,500 to invest. He's got 3 different ways he's going to invest it: mutual fund, a government bond, and a bank account. They each have their own interest rate. He has a total that he's going to invest, $10,500, as I said. He also knows that his investments, all total, the interest rates given above, are going to generate $825. He also knows that he's going to invest twice as much as in mutual funds as in his bank account. So the question is, how much did he invest each way? Can we essentially divine the way he distributed his money, his $10,500, simply by the information that was given? And the answer is yes, he did give us enough information. If he had he given us not enough, we wouldn't have been able to, but as it turns out he did. So let's discover how it happened. So what you have next is the series of 3, or the system of 3 linear equations. Notice they're linear because the variables that I've chosen are all to the first power. They simply have a coefficient on them. If you want to look at it this way, here's a little linear equation, just this piece right here. So this term is also linear, this term is linear. In fact, everything you see, all these terms on the page are linear terms or constant terms. Okay, that has to be the first thing that is happening. If the relationship involves things that aren't linear, this technique doesn't work. But many problems can be solved this way. So it's very useful. So what did I do? Let's take a look at this line first. First, I just added the 3 types of investments together. Remember, M is going to stand for the amount that he invested in mutual funds, G, the amount he invested in government bonds, B, the amount he invested in his bank. And he told us that it was $10,500 that it summed to. So I can just make up a little equation. The investments, I simply need to multiply each investment by its corresponding rate of return, and then that all together ended up being $825. And that last little fact, he invests twice as much in mutual fund as in the bank, can be written like this. He invests twice as much in the mutual fund. In other words, take the amount he invested in the bank, multiply by 2, and that's the amount that he invested in the mutual fund. Okay? All right, so how do we turn that into a matrix? Well, I've kind of got a pseudo-matrix here, a pseudo-matrix, to help you see how this happens. So if I compare the system of equations to this one, what happened? Well, I noticed, for one thing, I made sure that all the M's are in the one column, all the G's, all the B's, and all the constants that are on the other side of the equal sign are over here. So this one's pretty obvious. 0.11M, 0.11M, 0.07, 0.05B, okay? And then 825. This one is also pretty obvious. This one's not as obvious. So what happened there? And the answer is, I brought the 2b to the other side, and it became minus 2b. And I thought of 0 coming from 0 times g. So actually there is a g in here. Let's put it in. It's 0 times g, or just 0, right? And do you notice this 0 is this one right here? All right, that's kind of a pseudo-matrix, if you will. A real linear matrix that's useful is one that has just numbers in it. just the numbers. And these numbers are considered the coefficients. They will be called the coefficient of the matrix. So they come from the coefficients on each of the linear variables, and this is a column of constants that comes from the right-hand side. The right-hand side. So you can see this is pretty easy to follow, comes right from here. Notice there's a 1 in front of each one of these. 1m, 1 times g, 1 times b, so I put a 1 in there. And here I have 1 times m, no g, 0 times g, so 0, minus 2 times b, and here's my 0 over there. Okay? So this is how you take a situation, like that paragraph, that you can rewind the tape or the video and read again, and turn it into a matrix. Now, back in your other class, your intermediate algebra class, you would have been asked to solve this by hand. And one of the techniques would be to substitute 2b in for m. So you would have put a 2b here, and you would have put a 2b here, and then you would have combined the b's and combined the b's, and then you would have had to do an elimination of either b or g between these two to get g or b, and then you would have to do back substituting. So in this video and in these videos, we're not going to talk about that method. That method's really only good for systems up to 3, and it's still difficult to do at 3. We need a better system. We need to use the matrix methods, or in this case, we're going to call them the row manipulation methods to get here. Okay, next video is how do we solve this instead of doing it by hand.